All right, this video is to help my students with the Fab Five in physics. And they're right here. These are the fabulous 5 equations for constantly accelerated motion. Reminder that our first one is for constant velocity, so acceleration equals 0. So let's get started. The Roadrunner starts out with an initial velocity of 5.5 meters per second, accelerates a rate at 1.4 meters per second for 3 seconds. Determine the Roadrunner's final velocity. So I think what we should do is a chart where we have v initial, okay, and that was 5.5 meters per second. And then we'll have v final, okay, and determine the Roadrunner's final velocity. That's our question mark, what we're trying to find. Acceleration is at 1.4 meters per second squared. Our time is equal to 3.0 seconds. And displacement, this one's not mentioned though, so I'll put a little dash mark to that. So displacement is not mentioned in that. So then we need to pick an equation that has v initial, v final, acceleration, and t. I look over to my list. It looks like the fourth one down. V final equals v initial plus at. Then I can just plug that into the equation then. My v final is what we're finding. V final is equal to v initial, which is 5.5, plus acceleration, which is 1.4, okay, and then times 3.0. And then, of course, here we just multiply those two and add that together to get our v final. I will let you solve that for yourself if you want to do that. So that's one example of the Fab Five equations. Okay, next example. As ball is launched vertically upwards from the top of a cliff. Determine the maximum height for the ball above the cliff and the velocity just before it hits the ground. Okay, so let's get started again. Same chart. V initial. It looks like from the picture it's 14 meters per second. Okay, V final. Now we're solving for the first question. V final at the max height, the ball would stop moving. That would be 0 meters per second. Okay, that looks good so far. Acceleration, and again, that v final is not given. We have to infer that v final is 0 at the top of the max height. Acceleration is also not given. We would infer that to be gravity, 9.8 meters per second squared. We're assuming that there's no air resistance in the question. Time is equal to a question mark, but we actually don't need that one, so we can X that one out. Displacement is our real question. We really want to find out where the max height is, so that'll be our S variable there. So now we need something that does not have time in it, okay, and it has v final, v initial, and displacement. That's going to be this equation here, v final squared equals v initial squared plus 2as. Okay, so then I'll go 0 squared is equal to 14 squared plus 2 times negative 9.8 and multiply by s. And then we'll find out what s is. Again, I'll let you solve that, but think mathematically. I must take my 14 squared to the other side, so I'll have 14 squared, and that'll be a minus, is equal to, these two multiplied by each other would be negative 19.6 s. And then I end up dividing both sides by negative 19.6, and s would be by itself. All right, so that's the first question. Part 2, determine the velocity just before the ball, okay, hits the ground. Okay, so we're going to need a new chart, okay, and let me clear out this one here. So I'll go edit. Okay, let's clear the ink from the page here. Okay, so let's get started on this one here. Okay, so v initial is equal to 14 meters per second. V final is what we're trying to find out. And that'll be our question mark there, so we can put that in there. Again, acceleration is negative 9.8 meters per second squared. Time, again, is a question mark, but we need to not consider that. That's not been the one asked about. Now, S is going to be minus 30 meters. Why minus? Because we're starting here and we're falling 30 meters. Okay, now remember, this is the instant just before it hits the ground, so it's pretty much 30 meters. 30 minus an infinitesimal amount. So that looks to me like the same equation again. The v final squared equals v initial squared plus 2as. So I've got v final squared equals 14 squared, okay, plus 2 times negative 9.8 times minus 30. And here we don't need to solve for a variable over here. We can just take 14 squared, okay, and then add this expression to it. And remember to take the square root. And in particular, the v final this time is going to be a negative number. And again, I'll let you solve that. Why negative? Remember, when you take the square root of a number, you can choose the plus answer or you can choose the minus answer. Okay, it doesn't matter. Now remember, since we're going downwards, we're going to choose the minus answer to that v final. Okay, and that's how you use the Fab Five. Now I do have a quick application that can help you, okay, with these questions. It's a link next to this assignment. It's called the Fab Five checklist. And I'll just make up a hypothetical question here. Let's say I have an object with a beginning velocity of 5 meters per second. So I can write 5 meters per second here. And I'll click, that's a beginning velocity. And then it gives us a final velocity of 15 meters per second. So I put that in there and I check that. Okay, and it gives us an acceleration value of 1.5 meters per second squared. And I check that. Okay, and it says find the time it took for this velocity change to happen. So then what I'm going to do then is I'm just simply going to put a question mark, okay, inside this box here. And displacement I'll leave completely alone. And notice how I didn't check this either because we don't know it. That's the one we're trying to find, so I put a question mark there. So I can hit the show me button, okay, and then I'll bring this down for you if I can. Okay, I cannot. It reveals for you your Fab Five equation of choice is V2 equals V1 plus AT. So it's a way for you to check and see if you're doing the right equation. I'll click OK on that. And that's just an application you don't have to use, but it helps you organize things, and it'll allow you to figure out what equation you want to use. Hopefully that helps. Let me know if you have any questions.